for the 106th webinar, Engineers Talk, a weekly exchange of ideas through online being organized by IEI Salem Local Center. After a successful completion of 105 webinars by Dr. K. Tangaraj and Dr. C. Davamani as Chairman and Honorary Secretary of IEI Salem Local Center during the term 2023 and 2025, the same legacy now being carried over by the new Chairman, Engineer S. Loganathan, and Honorary Secretary R. Satish Kumar of the term 2025 and 2027. It's our pleasure to have you, sirs, for this 106th webinar. I welcome you both, sir. And now I would like to invite the Chairman IEA Salem Local Center to welcome the guests and the gathering. Please, sir.
Okay. Thank you very much, sir, for your nice introduction. So, first of all, I thank Dr. K. Tangaraj, immediate past chairman, and Dr. C. Davamani, immediate honorary secretary, for arranging or enhancing the knowledge of the our engineers through 105 engineers talk. It's a really a wonderful task, and also I thank all the members, Selvan sir, Kumaravel sir, and Armo sir, and the other personalities for involving this wonderful task for the past 2 years. So on this day, we are very happy to welcome Professor Dr. Pradeep Dal, Assistant Professor in KIT University, Bhubaneswar. So KIT University is continuously supporting us. So welcome, sir, Professor. Again, we are continuing this engineers talk in the forum in the different multiple area so that all the division engineers will benefit. In the today topic is intelligent AI solution for cancer identification in histopathological imaging. So it's a very tough one. So correlating the medical and engineering, especially computer engineering. So on this occasion, we really thank the professor for accepting this our invitation and for giving the lecture in the intelligent AI solutions, a very rare topic. So I was searched Google that what is the histopathological imaging means. The examination of tissues obtained by biopsy or surgical removal of an organ. So it's a very tougher one. So how we are introducing this AI solution to find a more practical and true solution for the these biopsies done in the hospitals. So hope Dr. Pradeep Dal will enhance us about the this complicated area. Sir, you can explain. We are all engineers, so you can simply integrate the engineering and medicine so that all the engineers can easily understand. And we continuously the continuous support of Engineer Arumugam sir for campaigning our Master of Ceremony for this entire program is a very worthy and notable one. So we thank you, sir, for your noble service for the Institution of Engineers, especially Salem Local Center, Arumugam sir. And we invite all the members present and senior members, committee members, council members for this meeting. And hope you will be here up to till the end of the meeting and interact with the our Professor Dr. Pradeep Dal. So welcome, sir, Dr. Pradeep Dal. So I am happily welcome all present here. And now the forum will be handed over to Dr. Pradeep Dal. Professor, now you can start, sir.
Yes, sir, please. Before that, let me introduce him.
Yes, I now request Engineer Arumugam sir to introduce the chief guest. Yes, sir.
Yes, sir. Yes, sir. Thank you, sir. Thank you for your welcome address.
Thank you.
Now it's my pleasure to introduce the chief guest and keynote speaker, Dr. Pradeep Dal. Dr. Pradeep Dal is currently serving as an assistant professor in KIIT University, Bhubaneswar, India. He has completed his PhD degree from the National Institute of Technology, Jamshedpur, India, and obtained his MTech degree in computer science from the Central University of South Bihar, Bihar. He also holds an MCA from the Institute of Technical Education and Research under Siksha O Anushantan University, Bhubaneswar. His professional experience includes academic and research positions in reputed institutions, and his research interests are machine learning, deep learning, image analysis, data mining, pattern recognition, and natural language processing. With these words of introduction, I would like to invite Dr. Pradeep Dal to present on the topic Intelligent AI Solutions for Cancer Identification in Histopathological Imaging. I welcome you, sir, to take over the session. Please.
Thank you, sir. Thank you, all the respected jury members. And first of all, a very good evening to all of you. Sir, I want to share my PPT.
Yes, sir, please.
Okay. Sir, is it visible?
Yes, sir, it's visible.
Okay. So today we will see the intelligent AI solution for cancer identification in histopathological imaging. So what is histopathological imaging? It is a very challenging area, as sir already told. So before that, we will see that why it is too much important to identify the cancer detection, early detection in histopathological imaging. So uh, towards these are the towards outline. First, we will discuss the introduction and motivation. After that, the basics of histopathological imaging, then representative case study, that the in this particular area from the about 2 years I am currently working. After that, smart and sustainable design principles. Then what are the various challenges are there towards this, and what are the future research direction and conclusion. Okay, so here as all of you know, all we know that the cancer is the very deadliest disease. So according to WHO report 2020, 19.3 million cancer cases has been reported, and 10 million deaths are reported worldwide. So here, so various causes are there cancer. So here lungs cancer, breast cancer, oral cancer, skin cancer, bone, gastric, colorectal cancer, prostate, stomach cancer, and majority of cancer cases globally, the cancer burden is shifting towards the low and middle income countries where the detection and treatments are limited, and also the doctors are very much limited. So, and according to WHO report, so by the near 2040, the cancer cases will be going to increase around 28.4 million cases. So here, aging population are significantly increasing global cancer incidence. So various are the risk factors are there, that pollution, diet, tobacco, escalating cancer risk globally. So why the early detection is needed? So early detection improves the survival by enabling timely and more effective treatment. Cervical cancer can be nearly 100% preventable through the early screening and vaccination. Colorectal cancer and caught early is often curable and minimal intervention. For example, breast cancer detected at stage 1 has 99% 5-year survival compared to less than 30% at the stage of stage 4. So early detection also reduces the need for aggressive and costly treatment like chemotherapy, radiology, surgery, etc., etc. The healthcare system impacts. Late stage cancer treatment is more resource intensive and also the sustaining healthcare system. Early diagnosis reduces hospitalization, ICUs, and need of complex surgeries. Cancer related healthcare costs are projected to expected 1.16 trillion per year globally. Mm. Early stage treatment often leads to faster recovery and return to productivity. Detection program lower the economic burden also on government as well as the insurance system, and workforce loses due to cancer related deaths, and this after that, the relevance to AI. Here, what are the role of AI to detect the cancer detection and digital health intervention? So, traditional, whatever the various approach, till now, various researchers are already working, applies various kinds of algorithm in for cancer detection. But the thing is that in medical, the accuracy is too much important. So here, but whenever we will try to adopt the biopsy images, histopathological images, then we can significantly improve the accuracy rate. So traditional detection approaches is not scale with the growing patient demand. AI-enabled tool can uh, democratize access to early detection in rural and undeserved areas. Digital pathology and AI reduces diagnostic turnaround time essentially for early intervention. Integrating AI into screening pathway offer a sustainable solution for universal cancer detection goals. So here also the data related challenges are there, means the data set. So lack of data scale labeled data set are there. Annotating the histopathological images require the expert pathologist, making labeled data scale. Data imbalance, certain cancer subtype are very less, causing data imbalance. So very less samples are available. Scanner variability, images from different scanners can have resolution and color inconsistency, and whole sides images are massive, demanding high memory and processing power. It takes large amount of memory to process that particular images. And the patch selection, so determining the reason in the whole side images to analyze is complex and as well as the non-trivial. And also the various privacy regulations are there. Legal and ethical barriers limit the data sharing, and also the class ambiguities are there. Some cancer types have overlapping all the features. Annotation and labeling. Annotation cost is very much higher. Expert annotation are expensive and also the time consuming. And here the sparse annotation is also there. Most datasets lacks pixel wise or the patch wise label. Lack of standard annotation protocol. No universal guideline exists for the labeling, and difficulty in validating annotation. Verifying labels is as challenging as creating them. And limited multi-class dataset. Multi-class dataset is very less amount of dataset is available for multi-class dataset. Many datasets are binary and limiting the model richness. Then the what are the motivations are there? Histopathological remain the gold standard, but it is time consuming and the labor sensitive. Rising global cancer burden demands scalable and accurate diagnostics tool. Inter-observer variability among pathologists introduce diagnostic and inconsistencies. AI can augment human expertise, reducing error and throughout bottlenecks. Sustainability ensure that AI system can accessible, cost efficient and the energy aware. Okay, now the what are the various types of histopathological image applications are there? No, first one is the breast cancer detection, identify invasive tumor grading, then the prostate cancer grading, after that the lungs cancer classification detect the small cells versus the non-small cell carcinoma using uh, then the colon cancer analysis evaluate mucosal invasion and architectural distortion. Liver disease evaluation detect fibrosis, hepatitis, etc. Then the skin lesion classification for skin cancer. Then the brain tumor analysis is also there. Then cervical cancer screening as well as the kidney pathology. Then now, here we will try to differentiate between the histopathological image and the radiological image. So here in histopathological image scale is microscopic, cell and tissue level, and in radiological imaging it is macroscopic, organ and body level. Then resolution, it is ultra high, too much memory is needed, single level visibility, and in radiology imaging it is moderate, limited to range. Then staining uses stain to highlight structure, for example HNE, IHC. These are the types of the in histopathological images. In the next slide we will see what are the various types are there in histopathological imaging. After that, in staining usually grayscale or limited to contrast agent. Then diagnosis is in histopathological in a diagnosis direct cellular level information we can get. It is the gold standard. Here for the diagnosis in radiology imaging, for example CT, MRI, X-ray, here the suggestive diagnosis often needs biopsy follow-up. Here the AI role.
Sir,
Pixel.
your voice is not audible.
Hello, sir. Hello.
No, sir, it is audible. Arumanga sir, audible.
Audible only, sir.
Audible, sir. Clear, sir.
Clear, sir.
Okay.
Okay, sir.
Then the AI role, here the pixel-wise classification we can process, and the morphometric feature extraction we can extract the various feature extraction texting by the deep learning. Here in the radiological imaging, most the detection, segmentation, and volumetric analysis and use cases is there: cancer subtype, grade, cellular, therapy margin, and in the radiology imaging, detection of tumor, organ structure, and lesion spread. And then data complexity, it is the as histopathological imaging, it is the very high memory is there in gigabytes, and it is comparatively radiological images lower, fewer images, lower resolution is there. Then what are the various types are there in histopathological imaging? H&E, most common stain for general tissue structure and cell morphology. Then IHC highlights specific antigens, for example, cancer biomarkers. Then the PAS detect glycogen, mucilin, and fungal organism. Then mesenteric, and after that, the silver stain identified the reticular fiber and some microorganism for the skin cancer detection in frozen section. Rapid frozen section. After that, the whole side images high resolution. So here in my in whole side images I have worked. After that, what are the various types of images in then in radiology? So first is the X-ray, a modality is 2D projection, for example, used for the bone fraction, chest and lung cancer screening. Then the CT images is there. It is the types of the radiology, either 3D cross-sectional imaging used for the tumor, organ damage, hemorrhage, metastasis tracking. Then the MRI, MRI images, it is the part of the radiology. Soft tissue contrast imaging and used for the brain, spinal cord, joint, liver tumor. Then the PET MRI is also there. It is radiological, functional imaging, cancer metabolism, brain activity. Then ultrasound, sound-based real-time imaging modality, and used for the pregnancy, and the mammography, low dense X-ray. Now, the how it helps over the other imaging. So first, in histopathological imaging, direct cellular insight we can extract. See the actual structure of the cancer cell and tissue. Stain variety. So here the HNE, IHC, PS, etc. reveal different features. Then it supports the ALML and high resolution level data, ideal for the deep learning. Then the molecular and genetic correlation can be linked with the genomics for integrating analysis. Then the quantitative morphology, cell count, nuclear shape, texture, etc. Then the global diagnostic report, the digital slides support the telemedicine and multi-center collaboration. Then this is the particular work that I have done, and it is published in Applied Soft Computing Journal. So here, for the prediction of oral cancer, we have used the histopathological images. Here, deep ensemble-based approach I have used. So why early prediction in oral cancer is needed based on the WHO? So high mortality rate, and according to WHO, over 50% of the oral cancer are diagnosed at the advanced stage, resulting in significantly lower survival rates. Improve to improve survival rates with early detection. Early detection of the oral cancer increases 5-year survival rate. Then more effective and less invasive treatment, then the lower healthcare cost for in early detection, after that the high prevalence and in developing countries, and last and a preventable risk factor. So here these are the main contribution is there. So here we have tried to develop a lightweight deep learning model. So here a lightweight short voting ensemble based deep network we have proposed predicting the oral cancer. So for that we have we have used CNN, BioLSTM as well as the BioGRU based block have been used to develop extract the deep feature through the histopathological data set. It handles variation in oral cancer data, ensuring reliable prediction across diverse population. It is computationally efficient and compared to other transformer-based model. And next contribution is here the CNN and BioLSTM block extract the spatial and contextual feature from the histopathological images. Also, the proposed by GRU work increases classification accuracy by exploiting spatial and sequential feature to better capture dependency within image data when paired with CNN. Then next, the deep features were extracted from the CNN, LSTM and BioGRU block are amalgamated to form a new set of deep feature. Here BioLSTM, BioGRU layer capture sequential and contextual relationship within the spatial features from the CNN block. And next contribution to forecast the probability of oral cancer among the unnoticeable patient during the screening. This study uses the short voting based ensemble classifier to classify after the deep features has been expected and from the proposed deep network. And here that also we have handled the class imbalance issue by integrating this approach. This research addresses high incident rate of oral cancer by developing efficient detection method. And this is the sample images. And so here you can see that this cancerous, 3 cancerous cells are there, and these are the normal cells are there, and already it is splitted by the pathology radiologist. And this is the proposed method. So here we have loaded input layer and then CN based extracted features, then BioLSTM based extracted, then and concatenated. Then after that we have used the voting ensemble based approach. So this paper is already there in Applied Soft Computing. You can browse and check, every details is there. Then so here the flowchart of the proposed method. So here we got the 90. So here you can see that the proposed approach got 97.89 accuracy for set 1. So 2 sets are there, set 1 and set 2. And here, by the precision of the accuracy, precision recall, and F1 score, F1 and ROC score, we have compared with other approaches. Now, the advantages of proposed methodologies are as follows. Early detection potential is there. So the model capability to predict the oral cancer accurately at early stages can lead to earlier intervention, improving patient outcome. Early detection of oral cancer is crucial. And then the multi-model feature extraction by integrating the three different and models, CNN, BioStem and BioGRU, then minimal pre-processing requirement, and then handle the non-linearities in image data, the combination of CNN and ensemble classifier, and then the less human dependency for screening. And other one is the flexibility and scalability. The proposed method is highly scalable. And then, so model efficiency and architecture. So lightweight and ensemble backbones. So for example, mobile net V3, efficient net V0 to reduce computation, model pruning, then ensemble distillation, and then these are the smart and sustainable designing procedures. So we can use the various deep learning methods to extract the deep features, and sustainable training strategies also there. Transfer learning, by using the transfer learning to rebuild to pretend histopathological backbone to avoid the full retraining, early stopping based on the precision loss, and another work we are doing, and it is under review in IEEE transaction. Then the various challenges are also there in histopathological images, as the image size is very large, and also the need of the expert annotation, and so we require the pathologist. Then the class imbalance or issue is also there, then the data privacy is there, then variability in staining, then domain shifting is also there, and hardware demand is also there. And very limited public data set is available for oral cancer prediction. Limited mean the only for the histopathological imaging. Then sustainable consideration, energy efficiency, training deep learning model consume large amount of electricity, and model sharing, reusing pre-trained model, avoid training from the scratch, and save energy. Federated learning and enables training without data sharing, and reducing data movement and preserving privacy, avoiding redundancy, train use many times across centers. Then what are the future research direction is there? Lots of future direction are there. A larger diverse data set is there, building the global data set with varied patient demographic and cancer subtypes, and then self-supervised learning, explainable AI, creating model that show why they make decision, help doctor trust AI more. This is the most important point. And then sustainable model training using low energy hardware or cloud server with green energy. And federated learning allow hospital to train model collaboratively without sharing patient data. Also, we are working in federated learning and in this particular area, and real-time diagnosis tool is also there. This work is already there. Now, the conclusion. So, histopathological imaging is the gold standard for the cancer diagnosis due to its have the ability for cellular level details. AI enhances diagnostic accuracy, especially in detecting early sign of the oral cancer. Deep learning is very powerful tool, but need clean, balanced, and level data to work well, and the collaboration between the AI expert and the pathologist is the key for building the usable system, and the open source and reusable AI tool can help reduce duplication and promote grid computing, and also the development in real time. A real world hospital needs lightweight model that were fast and accurate. And thank you. If you have any question, you can ask. And this work is already there in Applied Soft Computing. If you want to see, just a minute. Just a minute, is it opening? So it is already there. Every details is there. So if you want to get the knowledge more, so you can check this detail. So that's all from my side. If you have any question, you can ask. Thank you.
For any questions, sir, for further more clarifications? So, sir, one doubt. This AI software enabled deduction is mainly used for deduction, is it? Only if we have the either a photo image of the cancer affected parts or the biopsy images, we can detect whether it is a cancer or an ordinary tumor, is it?
Yes, sir. Yes.
Oh.
Sir,
If,
already data set is there. In that
ah,
particular data set, the pathologist already distributed that particular. These are the cancer patient
mm,
pathological images. It is the non-cancer type, and very less data is there. Researchers are working in this particular area.
pathological data is only the biopsy report, not the
Biopsy images, sir.
biopsy report images. Yeah,
Histopathological images, sir.
histopathological. Yeah,
Pathological images.
yes, yes. And suppose whether AI is really helping in the treatment of cancer.
Sir, actually,
Yes.
so the thing is that it depends. If
Mm,
we will collect very large amount of data, and
mm,
if we will train very large amount of data, then
mm,
at one time,
mm.
then we can see that the AI can predict, AI can give the best results, sir.
Oh,
So
oh,
for that
okay.
we need more data, sir.
More
But the
data.
data privacy is also there, sir. It is the very much challenging.
Yes, yes, sir. Actually, we have to provide the data support. And I want to know one more thing, sir. There are more sort of treatment methodologies. They can go for chemotherapy or radiology or immunotherapy or hormone therapy. So whether of these therapies, whether AI may have any suggestion over that?
Yes, sir.
Hmm.
Obviously. Yes, yes. You can do, sir.
Okay, okay, okay. Wow. At present, in which hospitals this AI support is being used?
Sir, actually, the thing is that in our university, KIMS super
Hmm.
specialty is also already there. So
Oh,
we
in
have
super
collaborated with
specialty.
uh,
Hmm.
we have collaborated with KIMS and Kalinga Institute of Medical Science, and they are
Hmm.
providing data, sir.
Oh,
So if you are interested, you can collaborate, sir.
okay, sir. Well, sir. Well, sir. Thank you. Sir, is there any further doubts, sir, from any other participant?
Sir, Pradeep, sir.
Yes, sir.
Yes.
Yes, sir. Which type of algorithm, AI algorithm used for this analysis, sir?
Sir, here we have used the deep learning approaches, and then we have extracted that particular feature, and then we will give that particular feature in ensemble based approach, and it gives very promising results, sir, for this particular oral cancer detection data, sir.
Hmm.
Sir, Professor Sir, any hospital are really using this, sir?
Sorry, sir.
Currently? Yes.
So pardon, sir.
Any hospital presently using this? I'm asking.
Sir, actually, we are collaborating with KIMS. Sir, I've already told. So if you are interested, you can collaborate, sir. Sir, then they will provide you, sir.
Oh, King Hospital.
KIMS, sir, Kalinga Institute of Medical Science. Super specialty hospital is there. It is the part of KIT, sir.
Oh,
So it is the part of KIT. So we are collaborating that. So they are providing data. So if you are interested, you can collaborate KIMS.
okay, sir. Okay, sir. Thank you, sir.
Sir, shall I conclude, sir? Shall we go for conclusion? Okay, thank
Yes,
you.
sir. Yes, sir.
Yes, sir.
Yes, sir.
Thank you, sir. Thank you, Pradeep Dal, sir, for throwing light on AI's role in providing solutions for cancer identification in histopathological imaging. Thank you very much, sir. Now, I would like to invite the Honorary Secretary of IEI Salem Local Center to propose vote of thanks. Please, sir.
At the outset, I submit my heartfelt thanks to our Chairman, Engineer S. Loganathan, sir, for his warm welcome to this wonderful program. I submit my heartfelt thanks to this today guest speaker, Dr. Pradeep Dal from KIIT University, Bhubaneswar, for his time and made on AI applications in histopathological applications. Thank you very much, sir. It's my pleasure to thank the team of Engineers Talk event of our IEI Salem Local Center, convener of the Engineers Talk team, Dr. K. Tangaraju, sir, members, Dr. C. Davamani, madam, Engineer Armugam, sir, Selvam, sir, and Dr. Kumanavel, sir, all the senior members and the student participants those who have attended this program. Once I am very happy to thank you all. Thank you very much.
Okay, thank you, sir. Thank you all. Thank you all.
Thank you,
Sir,
sir. Thank you very much. Thank you.
sir, shall I leave?
So, yes, sir, please, sir. Thank you very much.
Okay. Thank you, sir. Thank you.
Thank you. Thank you.